Hello, today I will try to show you how the control system works, the hydraulic gearbox, the PowerShift, and the electronic components that are part of the control system. The gearbox is controlled by a hydraulic distributor. This lever is responsible for shifting gears from 1 to 18. Here we have the clutch valve, which is responsible for starting the vehicle. Here we have the forward/reverse valve, position 0. This entire specialized hydraulic distributor unit is consistently supplied through the main line. This fitting by the hydraulic pump. The gear hydraulic pump consists of two parts. The first part of the pump, which is this part, supplies oil to the filter, then through a pipe to the distributor in the upper part of the gearbox. At this point, the oil is distributed to the differential lock, to the solenoid, to the PTO shaft solenoid, or it can also be a mechanical distributor depending on the tractor operated by cables. Next, it is directed to the oil cooler, which is located at the front of the tractor. It also plays a critical role in providing essential support to the tractor's overall braking system performance. Then it is also directed to the front drive solenoid. The front drive disengagement solenoid is located on the left side of the tractor. Behind the fuel tank, the clutch, when there is no pressure, is engaged by default. We disengage the clutch using oil pressure. Next, through this pipe, the oil goes to the gearbox distributor, and through the second pipe from the hydraulic control distributor. From the gearbox, the oil returns to the main clutch. The second part of the gear pump delivers oil to the filter and then to charge the multi-piston pump with variable output. And through this thick pipe, it also supplies oil to the distributor responsible for lubricating the gearbox. From this point, the oil is distributed. Lubrication of the gearbox, gears and clutches. When we use the tractor's external hydraulics, then the multi-piston pump draws a larger amount of oil from the charging system and a smaller amount of oil is supplied for lubrication of the gearbox. Therefore, when we use, let's say, double-acting external hydraulics, the oil then returns back through the distributor to the charging system and is used again for gearbox lubrication and charging. In these tractors, we cannot create a free oil return directly to the housing of the gearbox. Therefore, when we draw oil out, the pump supplies a large amount of hydraulic oil from the charging system. There will be a small amount of oil that will be directed to lubricate the gearbox system. And the oil will not return to the distributor, but will instead return somewhere else. In the gearbox, we will be lacking lubrication for the gearbox. That's why in these tractors, when we want to install a free return, we have to direct the oil to this spot. Here is an additional T-fitting, and here we direct the oil from the free return, which is then reused for the gearbox lubrication system. If we don't do it this way, we will have a problem with lubricating the gearbox. The gear lubrication pressure relief light will come on. Free runoff solution for these tractors. I consider it a disadvantage because it is known that free flow tends to keep the return pressure as close as possible. 0. In this case, it is impossible. Multi-piston pump. Mainly the power supply in the tractor. Steering system. Through the priority valve, which is located after the external hydraulics plates. This valve works in such a way that the steering system always has priority over the hydraulics. Next, it also supplies the lift and then powers the external hydraulic distributor valves. The distributor that controls the gearbox is operated mechanically by means of 3 cables through a single lever located in the tractor cab. There is a gear shift cable installed here. There is a clutch cable which is installed here. There is a drive cable for forward and reverse. The distributor supplies the gearbox clutches through channels and pipes. The lubricating oil enters the main gearbox housing unit via a sleeve that has specifically designed drainage holes and a central rotating shaft, which also is engineered with specific holes and high-quality Teflon seals. The oil is supplied through the hole in the sleeve to the hole in the shaft. There is a hollow channel in the shaft that delivers oil to the specific clutch. Through the holes and channels in the shaft, hydraulic oil reaches the clutch piston. By moving the piston, it clamps the discs. Now I will show how it works using air. I apply air to the given hole, press it, and we can see that the discs of the given clutch are clamping. The filling time is crucial for the proper operation of the gearbox, of the clutches. The pump, when we switch 2 or 3 clutches at once, is not able to supply enough oil to fill the clutches in a short period of time. That's why hydraulic gas accumulators are used. Hydraulic gas accumulators are constructed in such a way that there is a membrane inside the accumulator. In one part of the accumulator, there is nitrogen gas, in this case under a pressure of 9 bar. In the other part, there is oil. When pressure builds up in the gearbox system, the membrane is pushed, compressing the nitrogen gas. Then, this specific section is completely filled with oil. When we shift gears and need a larger amount of oil, but the pump is not able to supply the required amount in such a short time. From the accumulator, thanks to the pressure of the compressed gas and the membrane, the oil flows back to the distributor and the supply system of the gearbox, which shortens the delay in clutch shifting. This is important when we are switching 2 or even 3 hydraulic clutches. When the accumulators are faulty, we will notice that the tractor delays gear shifting. It may stop during shifting because the clutch baskets fill up too late. The clutches. That is why these accumulators are used, as they affect proper operation of the gearbox. It does not require any calibration. You just need to remember to take care of the accumulators so that they are always filled with the proper nitrogen pressure. As for gear shifting, the gearbox shifts very smoothly without any stopping. The only thing about these gearboxes is that this is the case in practically all of my Magnums, that between 6th and 7th gear there is a noticeable slight knock, while on the other gears everything is fine. I think this is caused by the fact that usually when we shift from 6th to 7th gear under heavy load, where the speed is low and 3 clutches are switching, that's why it happens, because the filling time is longer. But for example, when we shift from 12th to 13th gear, we already have higher tractor speed and the tractor doesn't slow down as quickly, so we don't feel that gear change. I don't know how it was with the new gearbox when the Magnum was new, whether it was noticeable as well. I can't say because I didn't have the opportunity to drive such a new tractor. The electrical part of the gearbox is very simple. The sensor we see here is a sensor that prevents us from starting the engine while in gear. Here we have drive forward, drive backward, and neutral position. When we're in the neutral position, we can start the engine, but when we're in reverse or forward drive, then there is a safeguard to prevent the engine from being started while in gear. Next, in the distributor, there is only one solenoid left, which is responsible for engaging the crawler gears of the reducer. Here, 2 wires also come out, but in this case, they are broken off. On the left side, next to the fuel tank, there is a lubrication pressure sensor for the gearbox. On the right side, there is an oil pressure sensor responsible for engaging the clutch plates. There are 2 sensors located by the filter, a temperature sensor and an oil filter clogging sensor. At the second gearbox filter at the back, there is also a sensor for oil filter clogging. There are two rotational speed sensors on the gearbox. The first sensor, which is visible, is located at the hydraulic pump drive. This is the sensor that indicates the engine speed. The second sensor, which we can see deeper inside, is the sensor that shows us the driving speed and the gearbox speed. The wiring harness that controls the gearbox is routed through the cabin from below. As for the electrical part, that's everything about this gearbox. And the information displayed on the screen, which shows us which gear is currently selected, works by the tractor's controller being programmed to read the difference in speed between the engine speed sensor and the gearbox sensor. For each gear ratio, it is properly programmed and displays the selected gear for us. If we have a situation where the gears on the display start acting up, changing randomly, or showing incorrect values, this indicates that something is wrong with the clutches and we are experiencing clutch slippage. Why is this gearbox like that? Durable and indestructible? In my opinion, this is because it is powered by a large gear pump which has high efficiency. All the lines supplying the gearbox are of large diameter, so we don't experience a drop in flow or pressure over their length. An efficient pump and large cross-sections of the lines supplying the clutches mean that the pump can easily supply all the clutches. And even if there are some leaks in the Teflon rings or in the clutch baskets, the pump is still able to supply the clutch basket, which means that there is no possibility. So even in the case of some leaks, pressure drops and damage to the transmission discs. That's why everything works without any problems for a long time. The gas accumulators are also of large capacity, which allows the clutch baskets to be filled. Clutches. There is no need to calibrate this transmission, and the entire control valve is operated mechanically. There is no electronics here at all, really, in this valve when it comes to shifting gears.